So I will introduce multiple linear regression in this video, and our starting point will be the simple linear regression in which we had a regressor or a descriptive variable or an independent variable, an explanatory variable, many names for this variable here, and we have a dependent variable, a response, you could call it, which we typically denote y. So we had two sets of data, two samples, x and y, and we want to see if there's a linear relationship between the two. We used the method of least squares to obtain the best linear fit, maybe something like this. And that's all fine. But what we do in multiple linear regression is that we add another variable, explanatory variable. See if I can add one here. So that is another x variable. So let's call it x1 and x2. And then in order to make a plot, we need, let me redo that, we need a three-dimensional coordinate system. And you can imagine these points are now points in space, hanging, floating around here in space. Here we have x1, x2, and the response here. And in our case, in the example that I'm going to do here, we keep our example with the pH and yield, but we introduce another explanatory variable, which is the temperature at which the process is conducted. And that gives us another dimension in which we can explain the position of these, with which we can explain the position of these dots here. So instead of doing a best linear line here, the best fit is not a line anymore. It will be a, let's use a green for that. It will be some sort of, not some sort of, it will be a plane. So a flat surface, and the way we find this, the equation of this surface, well, that's exactly the same as, I mean, we use the method of least squares, so we minimize the vertical distances of these points here to the plane, and that's how we find the best fit. So these are the residuals. Just as in the simple linear regression case here, this is the residual. So now it's just the vertical distance to the plane instead of a line. And this plane here has an equation because it has an intersect here with the y-axis, and it has a slope with respect to the x1 direction and a slope with respect to the x2 direction. So that slope here is beta 1, that slope over here is beta 2, and this intercept here is beta 0. So the equation of the plane is beta 0 plus beta 1 times x1 plus beta 2 times x2. So it's a first order polynomial in two variables. Let's look at how to do this in Excel. So here we have the data, we have the pH concentrations as before, and now we have the temperature as well, and then the yield. And the way we do it is exactly the same. We go into data here and choose data analysis, and then we find regression in this menu here. Choose that, and then we have to define the y input, the response, that's here, and the x input, that's these two columns here. Oh, that's a little too much. See if I can control this a little better, like that. And I'll choose labels here because I did mark the labels as well as the data, and I want the output to be in this sheet here, so I'll just choose this cell here, and let's look at it. And this, of course, is in Danish, but I'll do my best to translate. And we're not going to use much of this. We'll just take an overview here. Here we have the intercept, which is 59.05. The pH, so this is beta 1. This is beta 2. So those are the slopes with respect to the pH dimension and the temperature dimension. And we recognize this slope from before. And just like for the simple regression, Excel calculated the standard error here. And the t test statistic, the p-value, and the lower and upper 95% confidence intervals for each of these coefficients here. So nothing new except that we have another a new slope here. Let's note this adjusted R square here, the adjusted coefficient of determination. That's important now that we're in multiple regression. Sorry, that wasn't this. This was R squared. This is the adjusted R squared. Right. I'll talk about this one in another video, so I won't go into it here, but it has an important role in this multiple linear regression. Unfortunately, we cannot make a plot of these data together with the regression surface, so we'll do that in Python instead. Before we go to Python, just notice that I called this sheet, this Excel sheet, multiple linear regression introduction, because we're going to fetch the data from this sheet using the Panda package in Python. So let's go to the editor here, and the first thing we need to do is to import pandas, which is our data interface. I'll call it I'll refer to it as PD, and we import the matplotlib as PLT. We'll import NumPy as usual. We'll refer to it as NP, and then we need to import a toolkit, which is called mplot3d, because we want to do a 3D plot in this script here. And notice I already saved the file as a Python script, so the coloring is according to those syntax rules. So first of all, we'll do a plot of the data points. And before we do anything else, we need to convert the data into NumPy readable data. So what I'll do is first of all, we need to load. That's the first thing. So we choose the command read Excel, and I need to have the file name multiple linear regression introduction XLSX. So that's the the Excel sheet, and I use the command read Excel. If you need to load a package called something like RDXL or something like that in order for this command to work. If you haven't done it, you'll get an error message saying that you need to install this package, and you can do that using pip in the terminal. Right, and let's call this something. I'll call it Panda data. So that's my data in Panda format, and next thing I do is that I convert my Panda data to NumPy so that I can read the data in NumPy format. And I'll refer to this converted data as, I'll just call it data. So first we load it using Panda, and then we convert it into NumPy format. Let's just look at it. So I'll just run this script and let's see if it works. Something's wrong. Oh, there was a syntax here. Like that. Let's try again. Oh, and it wasn't able to find my, I believe I need a space here. So it's very important that you get the right file name. And of course the file should be in the same folder as the script here. And now it seems to be working. So the data is arranged as a matrix. These are the rows of the matrix, and it has 3 columns. So that's my data. It seems to be working now. Yes, this file here, this Excel file, should be in the same folder as this script that I'm running. So it seems to be working now. So what I'll do is I'll define a figure. Do that here. I'll call it fig. Using pyplot to generate a figure, and then I'll get the axis. I'll call them x. So from the figure, I'm getting current axis GCA, and I'm choosing a projection which is a 3-dimensional one, like that. So now we defined a 3-dimensional coordinate system, and using these axes, I can do a scatter plot. And what is it I want to plot? Well, I want some x, y, and z data, or rather x1, x2, and y data. So as you can see, the x1 data is all the rows in the first column of this data matrix. And the temperature data, that's all the rows of the second column, so that's column 1 in Python terminology. And then the third coordinate, that's the yield data, that's all the rows in the third column, so that's column 2 in Python. And let's give it a red color, like that. And let's show the plot. There we are. And you can see, if we look at the pH dimension here, and we just align it a little bit, you can see that there is a decreasing tendency here. As pH grows, the yield tends to decrease. And let's look at the temperature dimension here. It's always a good thing to look at your data before you do anything else, if you have that possibility. And here you see slightly increasing tendency. As temperature grows, the yield seems to be increasing, but the tendency is not so it's not so focused as it is for the pH. It's not so significant, I would say. But that's just my impression from looking at the data. Right. Let's just remove this. We've seen the data now. We don't need it. And we don't want to show this plot yet. We want to show it together with the regression plane. So let's make a plot of that. The first thing I'll do is I'll define my beta naught. So that's the intercept. And if I remember correctly, that was 59.05. Let's just check to be sure. The intercept 59.05, yes. And then we have minus 1.68 and 0.13. So beta 1 is, what was it? Minus 1.68. 0.68 and beta 2 is 0.13. And then I'll define a function. I'll call it y of x1, x2, and that's going to be my formula for the regression plane. So it just needs to return beta 0 plus beta 1 times x1 plus beta 2 times x2. So what I'm writing here is this equation, basically, the equation of the plane here. Right? And then I want to plot this. But because I'm doing a three-dimensional plot, I need to define not just an interval in which I want to plot. It's not enough to say what the intervals are. I need to create a grid, a mesh grid, which is sort of a, maybe we can go back here. It's like a matrix. I'll do it in blue. So it's a set of points. Let's say I want to plot from 0 up to 4, and I want 50 points here. I can't draw 50, but like 50 points here, and I want to plot from, let's say, I believe the lowest was 25. Let's say 20 up to 50 here, and maybe 50 points here, or 100 points, or whatever number of points. And that defines like a matrix of points. This is what we call a mesh. Obviously, I can't draw all these points, but just imagine like the x1, x2 plane here is scattered with points. And in each of these points, I would like to compute, the y value. So I get, a lot of points up here corresponding to these down here. This is the mesh. And in each of the mesh points, I want to compute the y value, and those points up here will then make up my surface plot. So I need to use the NumPy command called mesh grid, and then I need to define the x1 interval. I use the linspace command for that, and I want it to go from 0 to 4. That's the pH values, and I want 50 points. And for the temperature, I'll do another linspace going from 20 to 50 and taking 100 points. So that's my mesh grid, and I have to refer to it somehow, so I'll call it x1, x2. So x1 is a matrix which keeps track of the pH values of each of these points here that we talked about. Each of these points has a pH coordinate, and they also have a temperature coordinate, and that's what these two matrices keep track of. So we're ready to do the plot, and the command is called plot surface. It's part of the axis, and I want x1, x2, and my y values. Well, I get those by inputting the coordinates of each point into the y function here. So I'll just write y of x1 comma x2. Notice I used capital X's here because what I want to input into my function is these coordinates. Right. And let's look at it. So we'll show the plot and run the script. Whoa, that was a mistake here. Try again. And there we see our scatter plot together with our regression plane. We can see if I can align them a little bit. So we see it here from the pH dimension, and that's the plot we're used to looking at, so to speak, from the simple linear regression. And if we turn it down to see if I can rotate it so that it's we're looking at the temperature dimension here. It's a little hard to, yeah, there it is. So we see the increasing tendency here. Right.